Okay, students, from the last 4 classes, we are discussing graphs of real functions, and today we are going to discuss polynomial function. Polynomial function. What exactly polynomial is? Let us just first recall that we have already learned in earlier classes what is polynomial. Polynomial in degree n and in variable x is nothing but an expression of this type. Constant into x power n plus constant into x power n minus 1 plus up to constant into x plus constant, where definitely if it is called of degree n, then coefficient of x power n should not be equal to 0. I hope you remember all this. Yes, if this is a polynomial, then polynomial function is nothing but a function f from R to R defined as fx is equal to a polynomial in x. And this polynomial can be of any type. It can either be a constant, it can either be a linear, quadratic. If it be constant, then of this type. If it is linear, then it will be of this type. If it is quadratic, then it can be of this type. Cubic, any polynomial it can be. Okay, so a function, real function, fx is equal to some polynomial is called polynomial function. Now, to discuss about it graph, let us just discuss categorically. I mean to say, whenever a different polynomial is there, then there will be a different graph. So let us just discuss one by one. Constant we have already discussed in the first class of real functions. We have discussed constant function there. Now what about linear? Let us go for linear function. If it is a linear function, that means a function of this type. Fx is equal to a linear polynomial ax plus b. Okay, its graph would be a straight line. Its graph would be a straight line, and its domain will be all real numbers, and its range will definitely be all real number. You can see x can take any value and y can take any value. Okay, so domain and range both are real numbers. How to draw such graph? Let us just take an example. It definitely depends on the polynomial when it comes. Let us just take y is equal to 3x plus 2, suppose. Let us take some points x and y. If x is 0, then y would be 2. If x is 1, then y would be 5. If x is minus 1, then y would be minus 1 itself. Okay, let us just draw it. This is the x-axis. This is origin. This is y-axis. Now let us just put this point 0, 2, 1, 5. These are the points on the graph, minus 1, minus 1. That means line joining all these points. That means this would be the graph of this function. That means if the polynomial is a linear polynomial, then graph would be of a straight line. This is the graph of y is equal to 3x plus 2. Okay, simple to get. Yes, quadratic function. If there is a quadratic function, you can see any quadratic polynomial can be there. Let us just take a single standard quadratic. Fx is equal to x square, y is equal to x square type function. Its graph would be a parabola. This would be the graph of this function, y is equal to x square. Just see carefully what values x can take. Any real number, so its domain is R. And what values y is taking? All positive values and 0 also. So range will be this. It can be written as R0 plus. We have already discussed this symbol earlier. Now let us just draw it. For a quadratic polynomial, y is equal to x square. Let us just take some points. X, Y. If x is 0, then y would be 0. If x is 1, y would be 1. If x is minus 1, y would be 1. If x will be 2, then y will be 2 square 4. If x will be minus 2, y will be 4. Okay, so this means 0, 0, 1, 1, 2, 4, minus 1, 1, minus 2, 4. These type of points would be on the graph. And you can easily see these can't be joined by a line. Joining these points, we can see this graph. We can easily see this is symmetric about y-axis. And one more quality, you can see this 0, 0 will be called vertex of this parabola. Okay, symmetric about y-axis. Some observations you must remember. Symmetric about y-axis and its vertex is 0, 0. Okay. Now let us just observe if there is slight change in this expression, then what changes will be there in the graph. Let us just see. Suppose, let us just write it first. Again, y is equal to x square, then parabola will be of this type, vertex at 0, 0. Its domain will be R and range will be 0 to infinity. Okay. Now, if it is this x square plus 1, x square plus 1, that means if you put x 0, then y would be 1. Y would be 1. That means this graph will change to this. Vertex at 0, 0 is now changed to this vertex at 0, 1. Okay, 0, 1. And how will this change? Domain will be R. You can see there is no restriction on x. But y will start from 1. Least value of y will be 1. So range will be from 1 to infinity. Okay, 1 to infinity. Next, if the curve is of this type, x square minus 1, that means when we put x is equal to 0, y would be minus 1. That means this parabola will come down, it will pass through 0, minus 1. It will pass through this point, 0, minus 1. It will be its vertex, right? What is its domain? Again, there is no restriction in x. So, R is the domain. But range would be now minus 1 to infinity. Minus 1 to infinity. This would be the vertex and range will be minus 1 to infinity. It can be of this type, then addition is in x. I mean this. What will be the change in the graph for this? If y is x minus 1 whole square, then its graph would be this. You can see if we put x is equal to 0, then y will be 1. And if we put x is equal to 1, y will be 0. This would be the vertex. 1, 0 point will be the vertex of this graph now. And domain and range. Domain you can see no restriction on x. And range will be 0 to infinity. Domain will be all real numbers and range will be only positive real numbers plus 0. 0 will be also there. Okay. And if it is x plus 1 whole square, then this vertex will move to this vertex. Z minus 1, 0. Minus 1, 0 would be the vertex. Again, no restriction on x. So, domain is R. Restriction on y is for negative. That means range is from 0 to infinity. Okay, you can easily observe this from graph. Do remember, domain is what value x can take. Range is what value y will gain. Okay, let's just see one more modified form. If it would be the form x minus 1 square plus 1, then graph would be of this type. That means vertex will be at 1, 1, 1, 1. Vertex will be at this, decreasing from the left, increasing in the right. Okay, and its domain will be all real numbers. X can take any real number value, and range will be 1 to infinity. No value below this. Okay, and if it is minus 1, then this will move to this. Okay, these changes you must observe. Now vertex is 1 minus 1 point, domain is again R, but range will be minus 1 to infinity. Okay, for competition purpose you must observe all these changes so that you can easily judge whatever is asked. Okay, let us now move to another polynomial, cubic. Again, cubic can be of any type. We are taking standard one, x cube. Y is equal to x cube. Its graph would be of this type. You already know cube of a positive number is positive and cube of a negative number is negative. So whenever we take x as positive, then value will be on this side. Whenever we will take x as negative, it will be on this side. So this would be the graph, its domain, any real number, domain is the real number set complete itself, and you can see range is also all real numbers. Okay, y can also take any value. Okay, now let us just draw it. For drawing it, y is equal to x cube. Let us just take some values. When x is 0, y is 0. When x is 1, y will be 1. When x is minus 1, y will be minus 1. When x is 2, y will be 2 cube 8. When x is minus 2, y will be minus 8. Okay, so these value will be on the graph 0, 0, 1, 1, 2, 8. And minus 1, minus 2, minus 8 will be on the downwards. Okay, so graph will be of this type. Okay, graph will be of this type. I hope you have understood. Let us just see the changes in this graph also. This was the basic graph we have learned just now. Y is equal to x cube is the function. Its graph is of this type. Domain is R, range is R. Now, if it is x cube plus 1, then as we have seen in quadratic, again here this separating point, this point will move to 0, 1. 0, 1. The similar type of changes will appear in a graph. Y is equal to fx and y is equal to fx plus 1. In all such graphs, this type of change will come. Okay. Now its domain and range both will be same. You can see easily. Okay. If the graph is of this type, x cube minus 1, then this point will move to down. That means 0, minus 1. 0, minus 1. This would be the point where the graph will cut the y-axis. Okay. Same domain, same range. No change. Y is equal to x minus 1 whole cube. If the difference of 1 is from x minus 1 whole cube, then this will twist to 1, 0. You can see if we put x as 1, y will be 0. So, graph will touches the x-axis at 1, 0. Y is equal to x plus 1 cube. In the similar way, it will touches at minus 1, 0. Minus 1, 0. Okay. So, such type of changes you must observe carefully and remember to do questions of competitions very fast. Yes, let us just see quickly how the graph of biquadratic function will look like. It will look like same as quadratic because x4 you can express as x square whole square. It will be of similar type. In the same way, x power 5 will be of the type of cubic. So you must remember such observations for such graphs. Its domain will be R and range will be again 0 to infinity. Okay, so I hope these all observations will be helpful for you. That's all for the day. Next time, another function.